Good morning to everyone. I am N. Thirulmaisamy, Senior Lecturer, Department of Mechanical Engineering, Christian Polytechnic College, Oddanchatram. In this session, we are going to discuss about abrasive jet machining process. Last class, we seen about various types of abrasive machining process and non-traditional machining process and also unconventional machining process. In this session, we are going to discuss about mainly abrasive jet machining process. Session we are going to discuss about mechanical energy based process. The example is abrasive jet machining. In this abrasive jet machining, the material removal takes place due to the impingement of the fine abrasive particles. Here you see the diagram. The high velocity air with abrasive particle stream is passed through the nozzle and it will take impact on the workpiece. Here, the abrasive particles are typically 0.025 mm diameter and the air discharges at a pressure of several atmosphere. Here, we are maintaining the approximate distance. Stand-up distance is 0.8 mm to the workpiece and the nozzle. You see this diagram, approximate distance is 0.8 mm. Then, in this diagram, the abrasive jet machining process takes place by using nozzle with pipeline. Here, the abrasive particles with high velocity air passed through the nozzle and it will take impact on the workpiece. Then, what is mechanics of AJM, abrasive jet machining? Here, the abrasive particle impinges on the work surface at a high velocity and this impact causes a tiny brittle fracture takes place. You see this first diagram. Due to the high velocity force with the abrasive particles at impact on the workpiece, the material takes place fracture. The small material fracture takes place on the workpiece. You see this next diagram. After removing the material removal, the how it is cavity is formed. Here, the following air or gas carries away dislodged small workpiece particle. Then, what are the process parameters carried out this abrasive jet machining process? First of all, the process characteristics can be evaluated by judging the metal removal rate. Simply, we can say MRR. The second one is geometry of the cut. Third one, roughness of the surface produced. And final, the rate of nozzle wear. And also, the major parameters which control these quantities are: first one, abrasive. Abrasive particles include what are the major parameters means: composition, strength, size and mass flow rate. The second one is gas, that includes composition, how much pressure and how much velocity also included. Then final, the nozzle parameters are also considered as a geometry, material, distance from and inclination of the work surface. Then the main parameters of abrasive gas nozzle having various types. We will see one by one. First one, abrasive. Here the main abrasives are classified into two types. First one is aluminum oxide and silicon oxide. Here you see grains with diameter 10 to 15 microns are readily available for the aluminum oxide and silicon carbide abrasives. Here the mass flow rate of the abrasive particles mainly depends on the pressure and flow rate of the gas. Here you see the next parameter is gas. Here we are maintaining the abrasive jet machining unit normally operates a pressure level of the gas is 0.2 Newton per mm squared to 1 Newton per mm squared. Then finally the composition of gas and high velocity of gas significant impact on the metal removal rate even if the mixing ratio is not changed. Then next parameter is nozzle. Here the nozzle is one of the most vital elements controlling the process characteristics. Here the nozzle material should be hard to avoid any significant wear due to the following abrasive. Normally average life is considered for the nozzle 12 to 13 hours and sapphire position 300 hours we are using. And also for a normal operation the cross section of area of the orifice can be either we are using circular and rectangular type of the nozzle. Then abrasive jet machines working principle. First of all, starting from compressor, we are giving the high velocity air to the pressure gauge. It is passed through the pipeline. We are using filter to filter the dust and unwanted small particles. The relief valve is used to relieve the air with high velocity. The drain part is used to remove the dust particles in this abrasive jet machines. After that, the high velocity air is moved through the pressure gauge and also passed through the opening valve, and we have to maintain some certain pressure by using pressure regulator, and also finally it is moved high velocity air with mixing chamber. And also we are using abrasive particles also by using abrasive feeder. So both are mixing in mixing chamber, and air and abrasive particles is passed through the nozzle with some pressure. So at the time we have to maintain the stand-up distance. We have already seen this previous diagram 0.8 mm. At the high velocity air and abrasive particles are entered into the nozzle with high velocity force and also impact on the workpiece. It at the time the material removal takes place and also machining also takes place. Workpiece is holded by the fixer. We have to maintain the stand-up distance for the high velocity material removal. This is a working principle of abrasive jet machinings. Working of abrasive jet machinings. Here we are using the gas propulsion system supplies clean and dry gas. Here what are the particles means air, nitrogen, carbon dioxide to propel the abrasive particles. The gas may be supplied either by cylinder or the air compressor. You see, in this case, the compressor of air dryer may be used to avoid the water or oil contamination to the abrasive powder particles. And also the gas should be non-toxic, cheap and easily available, and should not excessively spread when over discharged from the nozzle into the atmospheric surface. Thank you. We will see the next session. Thank you all.